Okay, so we have a reaction. For example, hydrogen that reacts with nitrogen gas to give us what? Ammonia. You need to know this by heart, guys. Okay? And we need to balance this. How do we balance this? Okay, first one here. Don't use half. This one too? So we have 3 hydrogens, molecules, 6. 2 times 3 is 6. 2 nitrogens and 2 nitrogens. Okay? Now, these gases are going to occupy space. Now, how many moles in total do we have here? We have 3 moles of hydrogen plus 1 mole of nitrogen and 2 moles of ammonia. In this case, because we know exactly how we have here, and this is in equilibrium, so they are not going to be modified unless we have another concentrations, okay? But this is the amount of moles that we have in total. So we have 6 moles. Can we calculate the pressure that they will going to exert in a container? We have a container with a lid, okay, so the gas cannot escape. And we have the nitrogen, the hydrogen, and the ammonia mixed together. Can we calculate the pressure that they are exerting? Let's say that this one has a volume V that we know, 2 liters, 2 decimeter cube, or 1 decimeter cube, or whatever. Okay? What else do we need? Exactly. P V equals nRT. Okay? So V is one of the things that they give us. N is, what is N? The number of moles. Number of moles of what? Yeah, in total, the 6 moles. Okay? R is the it's the constant of the gases, and T is the temperature in Kelvin. So applying this formula, we can calculate the pressure, total pressure that we have exerted by all these gases together. The thing is that we need to know which is the pressure that exerts every single gas alone. How do we do that? We can calculate putting the formula, okay, and instead of putting N equals 6, we put the amount of moles for that particular gas. Yes? So we are going to have a pressure for the hydrogen, a pressure for the nitrogen gases, and a pressure for the ammonia. If we add them up, we have the total pressure, P. I'm going to put P total here. Okay, and if this is 6, this is P total. But we can calculate the pressure for any gas, and that is what we call partial pressure. Why is that important? Because we can say that the partial pressure is going to help us to calculate the Kp, which is the constant in equilibrium of the gas, the reaction in this case. But instead of using the concentrations, we use the pressure. So Kp is going to have exactly the same expression that we use for Kc, but instead of using the concentrations, we are going to use the pressure, the partial pressures. Now, in this case, we have the partial pressure of ammonia. So instead of brackets for concentration, we are going to use parentheses. P of the ammonia, NH3. Do you follow me? Which is the coefficient of the ammonia? 2. So we need to put this square. Yes? It's the same expression. And in here we have to put the pressure of the hydrogen. Exponent will be 3, okay, to the third power, times the pressure of the nitrogen, and that is going to be to the first power. Is that okay? Now, there is another way of calculating the pressure of each of the gases. If you have the total amount of pressure and you know which is the mole ratio of each gas, we can calculate the pressure by multiplying that mole ratio by this one, because the pressure is going to be even for each gas. Actually, it's not like that, because we take the gases as ideal gases, and we know that each gas doesn't behave like an ideal gas, but it doesn't matter. Okay, at this level we treat the gases as they were ideal gases. So every mole, it doesn't matter of which gas we are talking about, they are going to be occupying the same space, moving at the same speed, so everything is going to be the same. So we are going to calculate the mole fraction. Is the moles of this particular element, in this case hydrogen, divided by the total moles that I have. So in this case it's going to be 3 moles of hydrogen divided by 6, that is the total mole. So it's going to be 1/2. The mole fraction of nitrogen, and I put hydrogen molecule and nitrogen molecule, please, because they don't exist like that, is going to be 1/6, yes? And the mole fraction of ammonia is going to be 1/3. So if we calculate only once the total pressure of all the gases, and we multiply by the mole fraction, is going to give you the actual value for the partial pressure. Instead of applying the formula 3 times, you apply it only 1 time, you get this number, and this, then you multiply by this, and this, and you are going to have the partial pressure of each of them. Did you get it? Okay.